So you've got a metal control box here, and all of your electrical connections are going to be on the back. So those are all screw terminals. And then there's a programming port on top. It's USB type B. Once all this stuff's installed on the tractor, we're going to need to do a quick session on your laptop, just doing some calibration and adjusting the feed rates and stuff like that. So once you give it 12 volt power, it'll turn on, and what it does is it just this display is for actuator 1, this is for actuator 2, and this is for actuator 3. They're all labeled. The labels are going to fall off, so make sure that you maybe label the wires or something. So the buttons, we got a brightness here, it's a switch. So that's daytime mode. And that's nighttime mode. If you want dimmer or brighter out of those modes, that's where this programming port comes in handy again, so that could be changed. And all you do is you press a button to increment or decrement the linear actuator by 1 millimeter. So if you press down on actuator 1, it moves 1 millimeter down. And using a dial indicator, it's pretty accurate. I mean, it's very accurate for $160 linear actuator. That's the end of the travel. So about 667 there, 583. So the accuracy is about half a millimeter. There's nothing we can do about this. The control box is way more than capable of going down to like 0.001 millimeter. The actuators, however, are not. So that's the difference between a $160 actuator and a $1,200 actuator. But these puppies do 150 pounds of force, so they should be able to move the levers that control the seeder real easy. So that's pretty much all there is to it. You just gotta mount these actuators, run the wires. The sensors might have a little bit more of a voltage drop with the longer wires. So that's another reason why we're probably going to have to plug your laptop into it and make some slight changes. You'll know right away if you run these all the way down to 0 if it doesn't say 0. If it says like -1 or +1 instead of 0, that'll be a good indicator that we just have to plug it into the laptop. And it shouldn't take long to figure that out. So that's pretty much it. We call it the Seed Controller 9001. Alright, so we see all of our connections here. You've got your 12 volts coming in. And then actuator 1, 2, and 3 positive and then negative. If you swap these, if you reverse the polarity, never reverse the polarity on the input protection. And if you can, go for a 30 amp fuse. If you swap these, the motors will just run backwards, and what they'll do is they'll go all the way to the end of their travel because the feedback is programmed to stop it going the opposite direction. So anyway, positive negative actuator 1, positive negative actuator 2, and the same thing for 3. And for now I just have a little label on the actuators. That's the sunlight will actually, if the label doesn't fall off, the sunlight's going to fade that to the point where you can't read it. So you might want to mark the wires once you get everything installed. You might want to mark the wires on the inside of the cab with something more permanent. Then we have our blue wires, actuator 1, 2, and 3 blue. So that's our signal. Then actuator white is the last one. and the terminal block. And then you've got your actuator yellow. So when you got this, just desolder this wire right here and it'll pop right off. Alright, so here we have the control box, and this video is to serve as documentation purposes and also for later troubleshooting and anything else that might come up. So we have a metal box here, 3 displays, actuator 1, actuator 2, actuator 3, 3 sets of 2 buttons for open and close for each actuator. So these buttons control this display, this actuator. These buttons control this display, actuator 2. These buttons control this display, which is actuator 3. And this is a brightness switch, so up is bright and down is dim. Up here you have a USB Type B programming port. So on the inside, you can see you've got the buttons and the switch on one side and all the displays on the other. And those wires come up through a couple of grommets into the, I guess the main part of the box. So now what we're looking at here is the microcontroller, which is basically the brains of the operation. So here you can see we have 6 wires coming in for the buttons, and those are being read by the microcontroller. And then we've got our analog to digital converter down here, which you can see these wires coming off. These are going to feed off the sensor wire of the actuator. So the actuator has a total of 5 wires. The red and black is power to the actuator. None of this can be chassis grounded. Everything has, because the motor runs 2 directions, so you can't ground it to your chassis. It's got to come all the way back to the box. And then you've got 3 signal wires here which detect the position of the actuator. So the yellow is where we're applying 3.3 volts. The white is ground, and the blue, depending on the position of the actuator, is going to output between 0 and 3.3 volts. So this little analog to digital converter reads that voltage and it converts it to a digital value that the microcontroller can work with. And here we have a power supply. This is taking our incoming 12 volts and it's dropping it down to 7 volts. For the microcontroller board, the microcontroller board drops the 7 volts down to 5 volts and 3.3 volts. This is the USB programmer, which everything is RTV'd in place and lots of red Loctite. So this should stay in place pretty well. Just the tension of the cord should keep that plugged in there. There's not a lot of weight there, and hopefully you don't hear any weird vibrations. And last but not least, there's 3 independent motor controllers. Each one's capable up to 30 amps. The most you would ever see an actuator draw is a couple amps, maybe 2 or 3 amps. So the reason for being overpowered is because this doesn't require any heat sinks or any kind of cooling fan or any ventilation. So everything should run nice and cool with this in there. And those motor controllers are actually pretty cheap. Anyway, the downside is everything's really big. But this is a prototype, so that's how things go. Now if this works out great, all of this can be shrunk down very, very small. So the back cover is going to go on, and these wires here, these are our sensor wires. We've got our positive 3.3 volts and our ground, and then our 3 actuator sensor wires. And then each motor controller has a wire coming out that's going to go through the back and go to a terminal block. So it's basically going to feed through these holes right here, come out the other side, and then attach to here, and then you're going to connect all the actuators and whatnot on this side. And then we've got a Type A RAM mount. So I'm going to finish putting this together and we'll pick up there.